Hi guys, welcome to slope fields. The objective for this is if you're given a differential equation, DE for short, you're going to be able to sketch the slope field of the differential equation. A sketch of the general solution to the differential equation is the slope field. Okay, so we're going to get the general solution by looking at what we call a slope field or what's called a direction field. So they mean the same thing. You can see slope field or direction field, they're the same. Big note, you don't have to solve the differential equation to create its slope field. So that's a big thing here. We don't need to solve it to create the slope field of what this solution will look like. So let's look at two examples. In the first example, sketch the slope field for the differential equation dy dx equals x minus y for the following points, negative 1, 1, 0, 1, and 1, 1. So to sketch this slope field, if you think about it, it's actually just a field of slopes at particular points. Usually we use integer coefficients for x and y to help us, and it's a matter of plug and chug. So for example, if we look at the table here, 1 and 1, you're plugging 1 in for x, 1 in for y. So 1 minus 1 is 0. So I have the three dots. So at 1, 1, I'm going to make a horizontal line. So that little green line represents the slope at that point of my differential equation. If I use 0, 1, 0 minus 1 is negative 1. So I'm going to try to draw a slope that's negative 1. So at 0, 1, I'm going to go ahead and draw the slope down like that. What I think looks like negative 1. Okay, negative 1, 1. Negative 1 minus 1 is negative 2. So this slope should be steeper than this one. So if I look, I kind of have to estimate. And it's not going to be perfect. All I know is that it's a negative slope and it should be steeper than what this one is. So 0, 1, and negative 2 there. So that's how we start the slope field. And then that can just spread out over time. Okay, so over the field, as you pick more x's and more x's, you can plug in your y values too and find them. We just use ordered pairs. Okay, so let's look at one more example where we expand that out a little bit. Okay, so this one I filled in a little bit. Sketch the slope field for dy dx equals x over 2 minus y over 4. Okay, so you want to be very careful. I put a bunch of them up here. I didn't list them all. Okay, but what you still want to do is plug in specific values. So look at 0, 0. Well, 0 over 2 minus 0 over 4 is 0. So at the origin, look, there's 0. If I wanted to do 1, 1, okay, 1/2 minus 1/4 is a quarter. So this slope has to be pretty narrow, okay, or pretty level, I guess, not too steep. So I kind of guessed and said, well, I think this is about 1/4. Okay, so it's not very steep. So I go ahead and plug all these ordered pairs, each one for x and y, into my differential equations, and I get the following slopes. So I can look at, for example, negative 1, 0. So negative 1, 0, it's a negative 1/2 on the slope. So this is what I thought of negative half being, is like this. Okay, so there's my slope. So on the AP tests, they're going to be, if you have to draw this, okay, you used to have to draw them, but more than likely now they're going to give you a direction field or a slope field, and you're going to have to sketch the function inside there and do some things with separation of differential equations. But this is how we draw the slope field, and so the idea here is you pick specific x's and y's, plug them into your differential equation, find the slope, and then at that point, you draw what you think is the slope. So here, again, last one here, it looks like 0, right? 1 and 2. So 1 and 2, the slope is 0. 1/2 minus 2/4 is 0, so there's a horizontal line. So that's a slope field, partial slope field, that represents that differential equation. So if you guys have any questions or comments, go ahead and type them below. We'll see you next time.